If you are watching this video for the first time, make sure you are subscribing to Anantha Lakshmi Academy. Once you click on the subscribe button, you will see a bell icon. If you click on that bell and click on all, you will get to know whenever I upload a video. This will send you a notification. Hello everybody, welcome back to Anantha Lakshmi Academy. Today we are going to cover an important topic of similar triangles, which is areas of similar triangles. Today's topic is areas of similar triangles. Yes, even before this we have covered basic proportionality theorem, converse of basic proportionality theorem, exercise 8.1. Later we have also covered the theorems AAA, SSS, SAS theorems, and later on we have solved for the problems in exercise 8.2. Now we are going to getting to know about the concept of area of similar triangles. How do we define the areas of similar triangles? Even to understand this concept, we have a theorem stating how can we find the areas of similar triangles using the sides. So without any delay, let's get to watch it. And if you are directly coming to this video without watching theorems and exercise problems, you may be you will end up in small confusion. So better if you watch them before this video, you will have more clarity. All right, so let's jump into what the theorem says about the areas of similar triangles. So we have the theorem ready written on the board. This is 8.6, theorem number 8.6 in your textbook. All right, so let me read out the theorem for you. The ratio of the area of two similar triangles, as I have told you that this is a theorem which will let us know how do we figure out the areas of the triangles. So this states that the ratio of the areas of two similar triangles is equal to the ratios of squares of their corresponding sides. All right. So let me consider two triangles A, B, C, and what is the other one? P, Q, R. Okay, let us consider two triangles. What is given for us? What is given? Triangle ABC is similar to triangle PQR. Now, in order to prove this theorem, I am going to do some construction part. Okay, the next section is going to be construction in the theorem. What am I going to do is, I am going to drop a perpendicular from A to BC. Alright, AM, and I am going to name it as M. And in this, likewise, I am going to drop a perpendicular from P to QR. This is already Q, right? Okay, this is N. Okay, what is the construction that I have done here? Draw AM perpendicular to BC and PN perpendicular to QR. Okay, this is the construction part that I have done. So let's get into the proof. Okay, even before proof, what is that we need to know? We need to show what is that need to be proved, required to be proved. The RTP section is nothing but area of triangle ABC by area of triangle PQR is equal to, what is it? Is the ratio of the squares of their corresponding sides. If we consider AB in this, AB by PQ whole square is equal to, the base I am considering BC by QR whole square is equal to AC by PR whole square, the corresponding sides. That is the reason I asked you people to go through the earlier parts. Why did I write AB by PQ? We are looking at the corresponding sides. If you consider this side of this triangle, you need to consider the same side of this triangle. That's AB by PQ. Okay, that is how we will be writing. Let's jump into the proof. What is that we need to prove? First, areas, right? Let us take area of triangle ABC by area of triangle PQR. What is the area of a triangle? Why did I draw this perpendiculars to the bases? Because area can be figured out by the formula of half into base into height. Base we have, height we need to know, right? That is the reason I draw the perpendiculars. Okay, what is the area of triangle ABC? Half into base BC into height AM. And what is the other one? Half into, what is this? Base QR into height PN. Okay, let us have this as equation 1. Alright, now here look at this triangle ABM. ABM. Okay, also PQN. Okay, these are the perpendiculars drawn, isn't it? In triangle ABM and triangle PQN. Now, having said that this triangle is similar to this triangle, which meant that this angle is equal to this angle. Yes, angle B is equal to angle Q, since the triangles are similar. And now I draw a perpendicular in both the triangles, which is AM and PN, such that they are perpendicular to the bases. That is, angle M is equal to angle N. Now, two angles are similar. What is the similarity we have? AA similarity. By AA similarity, when two of the angles are equal, their sides are proportional, which meant their corresponding sides ratio is equal. So now I am going to write AM by PN is equal to AB by PQ. AB by PQ. Why did I write AM by PN? When you take this side of the triangle, you have to take the corresponding side, the same side, PN, and AB by PQ I took. Okay. Now, given that for us, what is given? Triangle ABC is similar to triangle PQR. So, similarly, what is given for us? Triangle ABC is similar to triangle PQR, isn't it? When triangle ABC is similar to triangle PQR, angle A is equal to angle P, and angle B is equal to angle Q, and angle C is equal to angle R. Alright, now when you have the angles equal, their corresponding sides ratio is also equal. So I am going to consider AB by PQ is equal to BC by QR is equal to, now the other side, AC by PR. Okay, what did I take? Since it is said that ABC is similar to PQR, I just took the corresponding sides ratio. Okay, now if you look at here, area of triangle, half gets cancelled. BC by QR you have. BC by QR, and AM by PN is nothing but AB by PQ you have here. And AB by PQ is also equal to BC by QR for us from the third equation. So from 1, 2 and 3. So from 2, if I am going to substitute this equation, second equation in here, I get this as BC by QR into AB by PQ. Now AB by PQ is nothing but BC by QR. So what happens? From 1, 2 and 3, I'll get it as area of triangle ABC by area of triangle PQR is nothing but, this becomes the whole square, AB by PQ whole square, which is in turn, AB by PQ is nothing but PC by QR, also equal to PC by QR whole square, and PC by QR is also equal to AC by QR whole square. So look at this, area of triangle ABC by PQR is equal to AB by PQ whole square equal to BC by QR whole square equal to AC by PR whole square. Hence, proved. I can leave this theorem to you guys to may understand, but most of the problems in next exercise are based on this particular theorem itself. So that's the reason I am explaining you, so that if you carefully listen to it, you will understand what are the sections that needs to be considered, especially when two similar triangles are given. How do we prove that their areas are equal and all? Okay, so quickly note it down. Just pause this video here and quickly note it down. And this is quite simple theorem from which we got to know that area of two similar triangles, ratios of areas of two similar triangles is equal to ratios of their corresponding sides, squares of the ratios of their corresponding sides. That's what we have proved using this theorem. Now this theorem is done, and I suggest you guys to go through the examples, because after this theorem I am going to jump into the exercise problems. So I hope you have already gone through the examples, and I am ready with the first problem of exercise 8.3 already written on the board. So let's get started without any delay. Okay, so let me write out the problem for you. D, E, F are midpoints of BC, CA, AB of triangle ABC. Okay, let us draw the triangle first. What is given for us? Of triangle ABC, there are midpoints D, E, and F. All right. D, E, and F of BC, CA, and AB. And now they are asking us to find the ratio of area of triangle DEF, the inner triangle and the outer triangle. Okay. So what is given for us? Solution given. First, what is given? D and E are midpoints of BC and AC. Okay. D, E are midpoints of BC and CA. So, when these are midpoints, the ratio of BD by DC, since these are midpoints, this point divides the side BC into two equal halves, and this one also AE, this point divides AEC into two equal halves. So I am going to write it as AE by EC. Now, we have a theorem called basic proportionality theorem, and we also have a theorem, converse of basic proportionality theorem. Converse of basic proportionality theorem states that when a line divides the two sides of a triangle into two in the same ratio, then that particular line is parallel to the other side of the triangle. So according to this, from CBPT, what is CBPT? Converse of basic proportionality theorem. What can I write? DE is parallel to AB. DE is parallel to AB. Okay, from converse of basic proportionality theorem, I wrote it as DE parallel to AB. Now, next thing is EF. I am going to consider E, F are midpoints of E and F are midpoints of AC and AB, which meant AE by EC is equal to AF by BF or FB. Again, from the same theorem, I am going to write it as, from the converse of basic proportionality theorem, EF is parallel to BC. EF is parallel to BC. Okay. Now again, FD, I am going to consider F, D are midpoints of, F is a midpoint of AB and D is a midpoint of BC. So AB, BC. From this, the ratio AF by FB. So if you are familiar with the theorems, basic proportionality theorem and its converse, then only you will get to understand what I am writing and how I am writing. That's the reason I suggest you guys to go through those videos wherein I clearly have explained how to take these sides and the ratios. Okay. F by FB is equal to BD by DC. Again, this side is dividing the other two sides into two equal halves. Hence, this line is parallel to this line. From the converse of basic proportionality theorem, DF is parallel to AC. Alright, let me consider this is 1 and 2 and 3. Now I said this side is parallel to this, okay, DE is parallel to AB, isn't it? DE is parallel to AB. Look at this one, BDEF. What is the polygon that formed? Look at this, BDEF. What is the polygon formed? This is parallel. This is also parallel. So we have a parallelogram. What is it? Parallelogram wherein this side is parallel to this side and this side is parallel to this side. So in parallelogram, what is the parallelogram? BDEF. In a parallelogram, since these are parallel sides, in a parallelogram, these two triangles, the diagonals, BDEF, if you look at this, since this line is parallel to this line and this line is parallel to this line, the triangles okay, here DF is what happens? DF is nothing but, in parallelogram BDEF, DF is the diagonal. DF is the diagonal. Okay, what is it? DF is nothing but, it is the diagonal. So in a parallelogram, diagonal splits the parallelogram into two similar triangles. Hence, can I say that triangle BDF is similar to triangle DEF? Yes. Yes. So in likewise, consider the parallelogram CDEF. Okay. In parallelogram, what is the name of the parallelogram? CDEF, CDFE or CDFE. What is the diagonal? DE is the diagonal. DE is the diagonal, wherein which divides the parallelogram into two triangles, which is nothing but triangle DEF and triangle CDE. So from here we can write triangle CDE is similar to triangle DEF. So how did I write? DF is the diagonal, PDEF is the parallelogram. That is based on these 1, 2, 3 equations. Okay, this is in parallelogram. Even before this, we were able to write this from 1, 2 and 3. Let me name this as 4 and this is 5. So here in parallelogram, we have one more parallelogram which is DEAF. Okay, in parallelogram DEAF. And what is the diagonal here? I told you, right? EF is parallel to BC. Diagonal EF is the diagonal. Now this diagonal splits the parallelogram into two similar triangles, which is nothing but triangle AEF is similar to triangle DEF. Okay, from 1, 2, 3 we formed the parallelograms, and from the parallelograms we formed the similar triangles. This is equation number 6. If you see this, this is BDF is similar to TEF, DEF is similar to CDE, and DEF is also similar to triangle AEF. Okay, now from 4, 5 and 6, I am going to write this as triangle BDF similar to triangle DEF, similar to triangle CDE, similar to triangle AEF. Now what are these? These are nothing but the small 4 triangles which are formed in the triangle because of this midpoints, isn't it? BDF is a triangle, DEF is a triangle, DCE is a triangle, and EFA is a triangle. So now area of triangle ABC is nothing but 4 times the ratio of 4 times the area of any of the triangles, since all of them are similar. Okay, now triangle ABC can be written as area of triangle ABC is equal to 4 times, because area, this triangle is formed with 4 triangles when we have the midpoints and such that they are parallel to one side of a triangle and intersecting the other 2 sides at 2 different points. We got to know that these all are forming a similar triangles, and hence area of triangle ABC is equal to how many triangles did we form? 4 triangles. 4 times of area of any triangle, either BDF or DEF or CED or AEF. Okay, now I am going to write it as DEF. Okay, because that is what is asked in the question. Okay, now DEF I took because that is what is asked. If you want, you can take the other also, but eventually at the end we have to prove that the ratio of triangle ABC and triangle DEF. Okay, now what is the ratio that has been asked for area of triangle DEF by area of triangle ABC? If I send it the other side, this becomes area of triangle DEF divided by area of triangle ABC is equal to what happens? I send this side, so it has to go this side. So this becomes 1 by 4. Nothing but this can be written as, this is also equal to 1:4. Okay. For the given problem, what we did is we just solved saying that one of the lines is parallel to one side of the triangle, and hence we proved that using the converse of the basic proportionality theorem. And later on we found the parallelograms, saying that the diagonal, when it is intersecting the parallelograms into 2 similar triangles, and eventually we came to a form wherein all the similar triangles are equal. And from there, area of triangle ABC is equal to 4 times the area of any of the smaller 4 triangles. Okay, 4 times any of the smaller triangles. So here we took it as DEF, and hence we figured out the ratio of triangle DEF to triangle ABC, which is nothing but 1:4. That is about first problem. Let's jump into the next problem. Here I have the 4th problem listed on the board. Second problem I am going to leave it for you guys to explore on yourself. If you are not able to solve it, please let me know. If you want me to solve it, please do write the same text in the comment section. I'll be solving for you in the later videos. And third problem is nothing but exactly the theorem 8.6, which I have explained you just before. It is exactly the same thing. So please copy that theorem in under the problem number 3. Okay, let's jump into now problem number 4. Triangle ABC is similar to triangle DEF is given, where BC is equal to 3 centimeters, CF is equal to 4 centimeters, and area of triangle ABC is 54. Determine the area of triangle DEF. First, what is given? 2 triangles, 2 similar triangles, A, B, C and DEF are given, isn't it? ABC is similar to DEF is given. Now BC is 3 centimeters, EF is 4 centimeters. Just before this exercise, we went through a theorem 8.6 which states that ratio of areas of 2 similar triangles is equal to the ratio of the squares of their corresponding sides, isn't it? So let me apply the same formula here. What did we figure out? Even before writing the formula, let's quickly write down the given section. What is given for us? Given BC is equal to 3 centimeters, EF is equal to 4 centimeters. Area of triangle ABC is 54 centimeters. Okay, centimeter square this is. Okay, now we know what do we know? We know a formula, right? Ratio of area of triangle ABC by area of triangle DEF is equal to any two sides corresponding ratio. Since BC and EF are lengths are given for us, I am going to consider it as the squares ratio, BC by EF whole square. This is what we have learned, isn't it? Triangle ABC is given for us 54 by area of triangle DEF is equal to what is BC? 3 by EF 4. So from this, can we get area of triangle DEF? Yes, we will take that the other side. Area of triangle DEF. If you take it the other side, this becomes 54 into this fraction. When it comes this side, the numerator becomes the denominator and denominator becomes the numerator. 4 square is 16, 3 square is 9. Alright, let's quickly do the simplification. 3 3s are 9, 3 1s are, 3 8s are. Okay, 3 6s are. Okay, so area of triangle DEF is equal to 6 16s are. 6 6s are 36, 6 1s are 6, 96 centimeters square. So what is it? Area of triangle DEF is nothing but 96 centimeters square. Alright, that is about problem number 4. Let's jump into problem number 5. Okay, it is already written on the board. Let's have a quick look at it. Here it is given that ABC is a triangle. Okay, ABC is a triangle. ABC. Now, PQ is a straight line meeting AB in P and AC in Q. Okay, PQ is a straight line meeting AB in P and AC in Q. Okay, if AP is equal to 1, BP is equal to 3, AQ is equal to 1.5 and CQ is equal to 4.5. Prove that area of triangle APQ is equal to 1 by 16 of area of triangle ABC. Now, we are dealing with a chapter named similar triangles. In order to apply the formula of area of similar triangles, first thing we have to do is we have to prove that these two triangles are similar. What are the two triangles? APQ and ABC, isn't it? First we have to prove them as a similar triangles and then we have to make sure prove that area of triangle APQ is equal to 1 by 16 into area of triangle ABC. Okay. Okay. Just a minute. Okay. So here, what is given for us? Given AP is equal to 1 centimeter. BP is equal to 3 centimeters, AQ is equal to 1.5 centimeters and CQ is equal to 4.5 centimeters. Generally, in order to prove two triangles are similar, either we apply side angle side, angle 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 or SSS theorem, side 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 theorem. But here we cannot specify on any of the angles because we don't know. But instead we have this sides. Okay, let me try figuring out. What am I going to figure out? AP by BP. AP by BP is equal to 1 by 3. Okay, likewise AQ by CQ is equal to 1.5 by 4.5, which is nothing but 1 by 3. Okay. AQ by CQ is equal to 1 by 3 and AP by BP is equal to AQ by CQ. So, which is that AP by BP is equal to AQ by CQ. If you consider this as equation 1 and this as equation 2, from 1 and 2, we can write this as AP by BP is equal to AQ by CQ. Now, the ratios are equal. I told you, right? When you get to know that the ratios of two sides are equal, then we apply the converse of basic proportionality theorem. What does it state? When the ratios of two sides, the two sides of a triangle are divided in equal ratios, then the line drawn is parallel to one of the sides, which implies PQ is parallel to BC. And this is applicable only in case of similar triangles. This implies that triangle APQ is similar to triangle ABC. Okay, what have we done? We tried figuring out the ratios of these two sides, whether they are divided in two equal halves. Yes. So, we said PQ is a line parallel to BC, and this occurs only in case of similar triangles. And hence triangle APQ is similar to triangle ABC is what we have proved. Now that we know, what do we know? We know that they are similar. So, for the similar triangles, we know the area formula, right? So, area of triangle APQ by area of triangle ABC is nothing but the corresponding sides ratio square. Now, what is the side that we need to consider? Let us consider AP. If AP is considered, what is the corresponding side in triangle ABC? AB. Okay. So, this is nothing but 1 by AB is nothing but AP plus PB, which is 1 plus 3 whole square. That is 1 by 4 square, which is nothing but 1 by 16. From here, I am going to write area of triangle APQ is equal to 1 by 16 times of area of triangle ABC. Check if this is what we need to prove. Area of triangle APQ is equal to 1 by 16 times of area of triangle ABC. Hence, proved. Okay. What did we do? We just tried figuring out if triangle APQ and triangle ABC are similar. How did we do it? By taking the ratios. Since the ratios are equal, we said those two triangles are similar. Once you know that they are similar triangles, we have the formula and we applied it and got the result. Alright, that is about problem number 5. Let's jump into the next problem. Here we have the 6th problem written on the board, wherein the areas of two similar triangles are given as two similar triangles. Let us take them as ABC and BEF. Okay. One is 81 centimeter square and 49 centimeter square. If the altitude of the bigger triangle, okay, let us consider ABB the bigger triangle, is altitude is nothing but this 4.5 centimeters. Find the corresponding altitude of the smaller triangle. We need to find, if we consider this as M, and then we have to figure out DN. Okay, solution. So, given area of triangle ABC is equal to 81 centimeter square and area of triangle DEF is equal to 49 centimeter square. Okay. If the altitude of the bigger triangle nothing but AM is equal to 4.5. Now, how do we determine this? Areas of similar triangles formula we have known, the same thing. So, area of triangle ABC by area of triangle DEF is equal to side square. Now, I am going to consider nothing but this side. Okay, which is nothing but AM by DN whole square. Isn't it? So, here that becomes 81 by 49 is equal to AM is 4.5 whole square by DN square. Write as 9 by 7 whole square is equal to 4.5 by DN whole square. Square gets cancelled. Now DN becomes 4.5 into 7 by 9. 9.5. So dn becomes 0.5 into 7 is 3.5 centimeters. Okay, dn is equal to 3.5 centimeters. So what did we do? We just applied the area of triangle ABC by area of triangle DEF formula, and we wrote it as the side square, which are nothing but the altitudes AM by DN whole square, and got the result as this. Okay, that is about exercise 8.3 of similar triangles. So if you like this content, if you think that the content is worth enough to share and you are able to understand, please pass it to your classmates and also any 10th class relatives in your circle. Also, please do like, share and subscribe to Anantha Lakshmi Academy. Thank you for watching.